I'm going to go over the basics of infiltration, give you some good rules of thumb, and show you how to calculate infiltration airflow. Infiltration is fresh, unconditioned outdoor air that is introduced to the building or the home through natural leakage. It's very similar to ventilation, except ventilation is intentional and infiltration is not. Like ventilation, it does have an effect on your load calcs. So the big question with ventilation is how much ventilation should I account for or expect? And that varies based on the construction of the building and particularly when it was built and what codes and standards were used. So here are some rules of thumb, some references that you can follow if you don't have a blower door test or really hard data on what the infiltration actually is. For old construction with little to no ceiling, you could expect around 0.5 to 1.5 air changes in infiltration. For typical construction, code minimum, standard stuff, 0.2 to 0.5. And then for energy efficient, really tight construction, 0.1 to 0.2, sometimes even less than that. Awesome. But those are air changes. How do we get this into a metric we can actually use for load calcs, actually get some value out of this? Here's the formula to convert air changes to an actual CFM number. It's CFM equals to the volume of the space times number of air changes divided by 60. To demonstrate, if I have a space that is 12 feet by 10 feet, my area is going to be 120 feet. If the height of the ceiling is 9 feet, then my volume is going to be 120 times 9, 1080 cubic feet. So that's volume. Checking our reference here, let's say we go with 0.5 air changes as our assumption. Our CFM is going to be equal to 1080 times 0.5 divided by 60, which comes out to 9 CFM for this space right here. To bring this to a useful conclusion, let's take this 9 CFM and use that to calculate the added load to the system. So the load equation, simplified, is going to be Q, our BTUs, equal to 1.1 times our CFM times our delta T. And that's the temperature difference between the outdoor air and your indoor set point. So if it's 100 degrees outside and you want it to be 75 degrees inside, then this comes out to 1.1 times 9 CFM times 100 minus 75. The delta T is 25. And the load becomes 247.5 BTUs, about 250 BTUs. Now, we could even use this calculation to develop a decent rule of thumb for infiltration. You could say at 0.5 air changes and a ceiling height of about 9 feet, you can expect roughly 250 BTUs per 100 square feet. So now that we have a decent rule of thumb for infiltration at 0.5 air changes, you can use this to calculate the infiltration for a 1,000 square foot home. So if your area is 1,000 square feet and we're assuming 0.5 air changes, a 9-foot ceiling, then your infiltration will add roughly 2,500 BTUs of load to the space. Quick reminder, if you like this stuff and you want to see more of it, let me know. Like the video, comment, or share it with a colleague. It really goes a long way.